Hello, guys. Our final project is looking at Thanksgiving data. I'm Chloe.
I'm Abby.
I'm Emily.
Yay.
So we'll start off with a little bit about our data set and some background and description of what the data that we collected is about.
Oh, so the first or the reason why we chose this data and kind of what it represents is that well, we initially chose it because we created the questionnaire around Thanksgiving time, around the holidays. So we figured why not ask about Thanksgiving, what people are thankful for, how many people attended their Thanksgiving. And so we created a Google form to ask some simple questions. And then to collect this data, I sent it to people in my sorority. I put it on my Instagram story, and then just tried to get it to as many people as possible. And then we ended up with 10 observations. I believe five of them or six of them are, or five of them are categorical or character variables. One of them is binary categorical, and then four of them are numeric. And then overall, we found 208 observations. And oh, additionally, we also posted it on Piazza because we needed to have more observations. And yeah, and so we will be making predictions off of this data, looking at it, analyzing it, seeing what it shows about people's Thanksgiving. Yeah.
Chloe kind of touched on this a little bit in the previous slide, but we had 10 variables. For categorical variables, we asked what your favorite Thanksgiving side was. We also asked where you go for Thanksgiving, what you're thankful for, what your favorite part of the turkey is, and whether or not Thanksgiving was your favorite holiday. That one was binary categorical, as it was a yes or no. And then for numerical variables, we had how many family members attended your Thanksgiving dinner. We also had if like what year your favorite Thanksgiving was, how many pounds your turkey weighed, and how many hours you spent cooking your turkey. And now we're going to move into the data preparation and summary portion.
So for starting with our data cleaning, that was the very first step we had to take, of course, and that took up a lot of our work time. So we had a lot of long column names because in our questionnaire, all the questions were posed as like a long explanatory question. So we cut those down, changed a lot of all the column names. Before we had a lot of multiple variations of an observation for the fill in the blank ones. For example, someone might have said for favorite part of the turkey, I don't eat meat, and another person might have said vegetarian. So we combined those, and the variables were not standardized. So for a lot of the ones where we'd asked for a number, but people still wrote in something else, we omitted those and converted the variables to numeric that needed to be numeric.
We also, oh, sorry.
So for the numeric variables,
Abby, could you go back?
Oh, sorry, my bad.
Yeah, we can talk about, I guess, how we cleaned specifically.
Okay, sorry, I thought there was a different slide. So I cleaned all the numeric variables. So for those, it was mainly just changing individual observations. So with the two brackets, the observation and the variable number. And then after I would clean as much as I could, I would just convert the whole variable to ask.numeric, and then summarize it from there.
And then I cleaned a majority of the categorical variables. With some of them, the spelling, like capitalization, was off. So I would make the whole column, like I would use two lower to make the whole column lowercase letters. And then, like Emily said earlier, some people would type things in, like if they were vegetarian and didn't eat turkey, or if in a meant to be numerical column, they said like, I don't know, for pounds of turkey or how many hours cooking. And so based off that, or that was more like for, I guess, numeric than categorical, but also for categorical, like for sides, one of the options was veggies, and some people would put like green bean casserole, even though I would consider that a veggie. So then I would like switch that, and just like mark that as veggie. And then also in the thankful column specifically, a lot of people had like options that would fit a different category, and the most common ones were family, friends, like life and health and that kind of stuff. So say someone said siblings, I would change their response to family because that fits into that. And then also some people would like capitalize friends and other people wouldn't. Or like some people would say friend and some people would say friends. So then I used if else statements and grepl to look at all the different options, and then I made it so that everybody spelled it the same way. And same with family. A lot of people said family. So if they said parents, I put them that option as a family member instead. And then I'd say the thankful column was the most like varied. So I tried to fit everything and like clump it down a little bit. Like I said, like putting siblings and parents into family, or like some people said alive as they're thankful that they're alive. So I put them as life. And yeah, so used a lot of grepl and if else statements, and then changing the specific like data point if it was like really out of the ordinary to like go with the data. But yeah.
While they were doing a lot of the data cleaning, I was doing most of the summary measures of the numeric and categorical variables. So just to kind of give a little overview of some of the stuff that we found, for family members, their respondents had a minimum of 1 family member and a maximum of 50 family members, with the mean being around 9 and the median being around 9 and the mean being around 10.53. Turkey pounds, the median was 12. The mean was also around 12.5. For favorite year, the median was 2021. The mean was 2020. Hours cooking, the median was 4 hours, and the mean was also around 4. For summary measures of categorical variables, for where you go, 19 respondents said their friend's house, 73 said the relative's house, and 116 said their house. For turkey part, 113 respondents said that their favorite turkey part was breast, which was the most popular, which was followed by leg, which had 36 responses, and then thigh, which had 27 responses, wing, which had 14, vegetarian had 8, and none had 10. Also, for favorite holiday, we had 178 respondents say no and 29 say yes. To continue explaining the summary measures of categorical variables, for favorite sides, the most popular were mac and cheese, stuffing, and mashed potatoes, with the other ones following. And then for thankful for, we also had a lot of different responses, but most popular were, like, as Chloe mentioned before, friends and family, life. And that was all of our variables. So now we'll move on to data visualization. So first off, we made a bar graph, and we did it to display our data for the question about what your favorite Thanksgiving side dish was. As I kind of just talked about, what we found was that the most popular side dishes were mac and cheese, stuffing, and mashed potatoes. You can also see the least popular sides, like sweet potato without marshmallows. We also did have sweet potato with marshmallows. But as you can see, there's a lot of variability around the favorite sides that people indicated that they had, but the most popular were mac and cheese, mashed potatoes, and stuffing.
So I created the box plot, and we were trying to find what the distribution of the number of family members attending Thanksgiving dinner was. So we used family members as our numerical variable. And I created this box plot. The median revealed that it was about 9. And then one of the major findings was that not only are there 4 outliers, so of like 30 or more family members, only 4 people had that many. But what it showed was that the bottom quartile range, the lower quartile range, was a lot smaller than the upper quartile range, which showed that with a median of 9, 50% had less than 9, but it was a lot more likely for those who had more than 9 to be more spread out.
And then for the scatter plot, we compared the amount of family members to the pounds of turkey. I feel like this one you would think kind of correlates. The more family members you would have, the more pounds of turkey, because the more people there would be to eat the turkey. So the data kind of shows with the dots that as the, like I kind of just said, as the amount of family members go up, so does the amount of pounds of turkey. I'd say like there were some outliers. Like if you see the person who had 50 family members had what looks like about 12 pounds of turkey, but there was someone who had 25 family members who had like 35 or 35 pounds of turkey. So there were definitely some outliers that you can see on the scatter plot, but overall, the relationship it like increases both ways. And then for a side-by-side box plot, we compared the people's favorite sides to the hours spent cooking the turkey. This data shows that the 2 variables are independent of each other. So say you cooked your turkey for 4 hours, it turned out amazing, it still wouldn't really change what your favorite side was. And yeah, that does make sense that they would be independent of each other. But yeah.
So I created the bubble plot and I was looking at the weight and time spent cooking a turkey in comparison to how many people attended, because similar to what Chloe said with her scatter plot, we would assume that the weight and the time spent cooking the turkey would be correlated. But what we found is that, especially once adding in that times variable, there wasn't really a strong correlation. So perhaps that means that people with more family members attending maybe just made more sides, and that didn't really influence their turkey. But I created this bubble plot and I changed the color based on where to go. So if they went to their friend's house, their relative's house, their own house, because that ties in to our later regression models when we were looking at if how many family members they had were to impact that and such.
And then for our special plot, I made a word cloud of the what are you most thankful for variable. As Chloe has mentioned earlier, this variable was very messy, and so it took a lot of cleaning to get it down to the number of responses that you see displayed on this graph. But I think it's really nice to look at this graph because it gives a pretty nice depiction of how frequently people gave certain responses for this. As you can see, family and friends are the largest responses. It appears as though family is slightly bigger than friends. There's also big ones of pets, life, health, UVA, religion. And that's that with the word cloud. So next we'll talk about the regression models that we made.
So for simple linear regression, we tied in the amount of people and the pounds of turkey, kind of like we did earlier for the scatter plot that I mentioned. So like I said before, the amount of people you had would be related to the amount of pounds of turkey. So we created a simple linear regression model off of each other because these 2 variables were pretty dependent on each other. And so using a predictor or an individual, we found that if you were to have 10 family members, you were most likely to have around 12.3 pounds of turkey. So yeah.
Then for our logistic regression model, our response was where you go for Thanksgiving. We made a new variable that was binary categorical of if you go to your house or somewhere else. So we combined friend's house and relative's house to make a new category called elsewhere. And so we tried to use our numerical variables to predict whether or not you go to your house or elsewhere. The only variable that was found to have a correlation was the number of family members. But that one did have a relation. So we used that to create our logistic regression model. And then with that model, we made a data point for someone with 4 family members whose favorite Thanksgiving was in 2022. The turkey that they had was 12 pounds, and that turkey cooked for 4 hours. And then based off of those data points, our model predicted that they would have Thanksgiving dinner at their house and not elsewhere. Even though our model didn't find correlation between the other numerical variables other than family members on where you go for Thanksgiving, we still had to include them when we made our data point to add for our prediction. But the final model only made the prediction based on how many family members. And as I said before, it predicted that the individual would have Thanksgiving dinner at their house. And now we're going to move on.
So finishing up with classification, first off, I was looking at the relatedness of an individual's favorite side and what they're thankful for, compared to what their favorite part of the turkey is. And I chose those variables mainly because favorite part of the turkey, while it wasn't binary categorical, it did only have a few options. So I thought that might be an easier thing to find relation to than say if we did what they're thankful for, or even what their favorite side was, because there were more options in the variable for that. So as shown in the graph on the right, the highest accuracy is with 9 neighbors. And when given the options of breast, leg, thigh, wing, vegetarian, or none, I made a prediction model, and an individual whose favorite side is mashed potatoes and is thankful for family is most likely to choose the breast of the turkey as their favorite part. And this makes sense because mashed potatoes was one of our most common responses for favorite side, and family was our most common response for what people are thankful for. And the breast of the turkey was overwhelmingly the most commonly favorite part of the turkey.
Yay.
Yeah, if you're interested, we've included a link to the Google form that we sent out for our data collection. But that is it. Thank you so much for your attention.
Thank you.
Thank you.